Okay, let's talk about scientific notation. Scientific notation is pretty neat because it's a way of expressing numbers that are either too big or too small to be written in decimal form. It's really about convenience. And it's going to have this format. Its format is basically a number, which I'm using the letter M right now, times 10 to the nth power. And I know what you're all thinking. Is it okay that we're using a time sign here, like the old school time sign? And the answer is yes. It's the only time we can still use the X for multiplication. But back to these numbers. The M, that leading number, is actually needs to be between 1 and 10. It's allowed to be 1, but it's not allowed to be 10. So basically a decimal number from 1 up to 9.9999. And then times 10 and to an integer. And that integer, remember, an integer can be positive or negative. So if that n exponent is large, that means we're talking about a number that is too big. If that n is negative, meaning we're talking about a very small number then. It doesn't mean the number itself is negative. It just means that we're talking about a decimal number. Let's take a minute and look at the directions about how to convert numbers into or out of scientific notation. Hopefully you remember this from science class in the past couple years, but working with scientific notation, if we're going to go through and start with having a decimal number, just a standard number, and convert it to scientific notation, we have to start by finding the decimal point, and we start by moving that decimal point to make that leading number bigger than 1, but again, smaller than 10. Then we just go through and we count the number of spaces the decimal point moved. It's not about the zeros. It's about the number of spaces the decimal point moved, because that's going to be our exponent. We'll then multiply by 10 to the exponent. If the exponent is positive, or the exponent is positive, if the original number was greater than 10 or less than negative 10. Okay, we're talking about big numbers. The exponent is going to be negative if the original number was in between -1 and 1. Again, we're talking about a small decimal number there. So if we take a minute and we look at these two examples here down at the bottom, and I start by finding where the decimal point begins. So in a regular number, this negative 480 million, the decimal point is there to the right. And so that means I'm going to go through and I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8 times to get it there between the -4 and the 8. So I'm going to have that as my leading number, -4.8. times 10 and then to the 8th power, because this number was really big negatively, but really big. If we look at that next number, really tiny, 0.0000116. So we're going to go through and again, we're going to move that decimal point 1, 2, 3, 4, 5 times to get it between 1 and 10. So it's going to be 1.16. times 10, and it's not just going to be 5, it's going to be -5. We move the decimal point 5 times, but since that number is really small to begin with, it's going to be a -5. Now, when we switch to looking at taking scientific notation back to a regular number, it's going to be all about identifying, sort of like the reverse process here, looking to see if that exponent of 10 is either positive or negative. If it is positive, we're going to move the decimal to make so that the number is bigger. Okay. If that exponent is negative, we're going to move the decimal point so that the number itself becomes smaller. And then we just use zeros to sort of fill in the spaces. So if I look at my first number here, this 9.884 times 10 to the 4th. Even if you stop and think about this, 10 to the 4th is basically 10,000. 10 times 10 times 10 times 10. So I'm taking a number times 10,000. It's going to get bigger. And it's going to get bigger by moving my decimal point 4 spaces. So 1, 2, 3, 4. I'm going to end up needing 1 extra 0 at the end of my number here when I'm done here. So it actually works out to be 98,840. Now, my next number with an exponent that has a -4, that means I need to make and move my decimal point so that my -7.2 becomes smaller as a decimal. So I'm going to move the decimal point 1, 2, 3, 4, and I need to fill in with zeros. So 0, 0, 0 in there. So my final answer will be 0.000 72, and it was a negative there, so I'm going to put a negative on the outside of that number there so that the number itself stays negative. It's that simple to move things around. Now let's look about making sure numbers are going to be in scientific notation correctly. These last two examples are almost like scientific notation. They're close. I will remind you that scientific notation is like working with exponents. Okay, so those exponent rules sort of still apply. So if we stop and we look at these first examples here, and we have this 53 times 10 to the third, it's almost scientific notation. That 53, I'm going to start with, and I'm going to take that 53 and convert it into scientific notation. So it's going to be 5.3 times 10 to the first, because I had to move the decimal point one time. But I still have this times 10 to the third from the original problem. And hopefully you remember, if I have same bases, I can add my exponents. I have 3 10s there and another 10, so that's 10 to the fourth, with that still that 5.3. Look at the other one. I have this 0.075 times 10 to the negative fourth. But if I take the 0.075 and I'm going to convert that to scientific notation. So that means I need to move the decimal point 2 places. So times 10 to the negative 2, because that number was really small to begin with. I still have this times 10 to the negative fourth here. So again, whenever I go through here, I keep my base of 10 and I add my exponents. Negative 2 plus negative 4 is negative 6. And I still have that number of 7.5 to lead out with. Working with scientific notation is just a matter of being comfortable with your exponents and basically your powers of 10, which is moving your decimal point.